Hi folks, I want to talk a little bit about the histogram again that we encountered in the data analysis tool. Histograms are two-dimensional graphs. On the x-axis we have the value or the outcome that we're measuring, the metric. On the y-axis we have the frequency of occurrence of that measure. So let's say I had a group of people that came in and I asked them how old they were, and I wanted to put them into a histogram. I might create bins, and we'll talk about what a bin is, of individuals from 19 to 26, from 27 to 30, from 31 to 42, etc. Those would be our bins, and we take individuals and say, you get into that category, and then I would count the individuals in that category and say, okay, I have this number of individuals, this frequency for that bin. So let's get out of here and go back to Module 1 practice exam, the Novice exam. And let's look at the data that we had for page views and shoppers. So here's our data. Previously what we did is we created bins for our data that counted specifically the number of times that 4 occurred. So for example, this bin, the top of this bin is 1, so it's going to contain 1 in everything below, 0, negative numbers if we had them. And there are 4 numbers that fall into that bin. So let's see. Here's a 1, 2, 3, I must have missed 1. 1, 2, 3, and 4. 6 occurs 5 times. 1, 2, 3, 4, 5. So our frequency distribution, our tabular form of our frequency distribution that we did before provides that. Now, we just assumed we wanted bins with these individual values. What if you wanted bins that had less acuity, less granularity? I've created a new set of bins over here that are 2, 4, 6, 8, 10, and 12. Bin 4, for example, will count the number of values that we see in this column of numbers that are either 3 or 4. This is the top of the bin. You can think of these as the top of the bin. The top of this bin is 2, so if something has a value larger than 2, it's not going to go in this bin. It's going to look at these other bins to see where it fits. So here we have values between 5 and 6, here between 7 and 8, here between 9 and 10, and here between 11 and 12. So I've got my bins. Let's go to data analysis and see if we can generate a new distribution, frequency or histogram. I often call this a frequency distribution because that's what it is. All right, let's grab our data first of all. There's already data in there from previous engagements. It remembers what you did before. So there's our data. The new bin range now is here. I didn't grab the titles, so I'm going to take that off. And if I had grabbed the titles, then I'd have to do it for both the input and the bins, and so new bins would be in there. Otherwise, it mistakenly would give you kind of an odd-looking set of output. Let's hit the output range to be here in M31. We want a chart output, so we put a tick mark there. Let's hit OK. Non-numeric values. Let's go back to our data. I must have grabbed the title there. That's what happened. So let's see if we can go now. Yes, now we've got it. Here's our tabular frequency distribution, and here also is the graph. So as you can see, it has a different look. Why? Because for bin 8, there are 7 values. You can see with that mouse over gives you a view of how many values in there. That must be between, that are 7 or 8. Okay, 7 or 8. So there's 1 7, 2 7s, an 8, an 8, another 7, an 8. So I think that gives us the required number of 7. All right, that shows you how you can use different sets of bins to create a different look. It depends upon how much granularity you want. You want to make sure that you include values in a way that the space between bins is the same. It doesn't have to be, but if you don't do that, for example, the space between 2 and 4 is the same as the space between 4 and 6, you're going to get this distortion that you're not going to see on the x-axis exactly what's happening. All right, I hope that helped. This concludes this video.